All right, ready to geek out on some geology with me today?
Always.
Today's deep dive, we're talking all about hematite.
Okay.
You think you know it, right? It's just rust.
Right.
But trust me, this mineral has some hidden depths that'll blow your mind. We've got excerpts from Wikipedia and Mindat, and let me tell you, this goes way beyond rusty nails. Get ready for ancient pigments, shimmering crystals, even formations called iron roses. Mother Nature's got a metal side, who knew?
Yeah, it really is amazing how deceptive appearances can be. We see rust everywhere, but the way that hematite forms, its crystal structure, links it to, believe it or not, gems like sapphires.
Mm.
Same basic blueprint, different elements, totally different vibes.
Okay, hold up. Back up the sapphire train. We're going from rusty tools to precious gems. This is why I love these deep dives. So let's unpack this. We've got those ancient pigments, cave paintings old, right? But what's the connection to sapphires?
Yeah, let's start with those cave paintings. We're talking 164,000 years ago in South Africa. That's not just art. That's early humans using hematite to communicate, to leave their mark. And you mentioned the sapphire connection. It's about their shared rhombohedral structure.
Okay.
Imagine a 3D shape, kind of like a squished cube. That repeats. Hematite and sapphire share that, but their chemical makeup is totally different.
So same building blocks, wildly different results. That's fascinating. But back to those ancient artists for a second. They weren't calling it hematite back then, were they?
You're right. They had some pretty evocative names for it. Sil Atticum, Caput Mortimum. Sounds more like a wizard's shopping list than an art supply store.
Right?
And those names tell us something about how they used hematite.
Okay.
Sil Atticum refers to a specific type of hematite, super fine-grained, prized by the Romans. Then you've got Armenian bole, which is a clay rich in hematite, used for centuries in gilding.
Hmm.
Think illuminated manuscripts, ornate furniture, all getting a touch of gold from hematite.
Wow, so this one mineral has been used to capture everything from the earliest forms of human expression to the fine details of a gilded manuscript. That's quite the resume. But why red? What's the science behind hematite's color palette?
It all comes down to iron. Hematite is iron oxide Fe2O3, and it's the iron that gives it that distinctive red streak, no matter what form it takes. It's like a fingerprint, a surefire way to identify hematite.
So that rusty red isn't just surface level, it's baked into the very essence of the mineral. And speaking of baked in, that iron content is also why hematite's been used to make, well, iron for ages. Swords, tools, the whole shebang.
Exactly. For a long time, hematite was the iron ore, driving innovation from the Bronze Age to the Industrial Revolution.
Okay, but now for the curveball magnetism. MnDOT talks about this magnetic hematite being sold as jewelry but calls it out as a fake. So which is it? Is hematite magnetic or not?
This is where it gets really interesting. Hematite is technically magnetic,
Okay.
but it's way weaker than its cousin magnetite.
So those hematite bracelets promising to align your chakras are a bust.
Let's just say the science is shaky. Hematite's magnetism is way too weak to have any real effect on the human body. Now, the way those iron atoms are spinning within the mineral, that's where the real magic of magnetism happens. But we'd need a whole other deep dive to unpack that.
Challenge accepted. But for now, let's stick with our current mystery mineral. Mindat also mentions something called the Morin transition. Sounds a bit ominous, right?
It's not ominous, but it is fascinating. Basically, the Morin transition describes how temperature affects hematite's magnetism.
Wait, hold on. You're telling me this already weakly magnetic mineral changes its magnetism based on how hot or cold it is? What does that even mean?
It all goes back to those iron atoms and their arrangement within the crystal. Below -23 degrees C, hematite behaves magnetically differently than it does at higher temperatures. It's like it has a magnetic switch that flips.
Okay, mind officially blown. This seemingly simple mineral is full of surprises. Speaking of surprises, this Mindat article mentions hematite hanging out in some unexpected places, like Yellowstone National Park.
And it's not just there for the sightseeing. Remember how we talked about iron being dissolved in water?
Mm-hmm.
Well, in places like Yellowstone's hot springs, hematite can precipitate out of that mineral-rich water, and over time, those deposits create vibrant colors.
So we've got this one mineral coloring ancient cave paintings, Andy Yellowstone's hot springs. That's wild. This deep dive just keeps getting better and better.
And we're just getting started. What if I told you that hematite might even hold clues to life beyond Earth?
Okay, now you're just messing with me.
I wouldn't dream of it.
Ah.
But we might need to save that story for part 2 of our deep dive.
All right, you left us hanging with that extraterrestrial cliffhanger. Before we blast off into space, though, I gotta know more about this whole hematite as a clue to life thing. What's the connection?
Yeah, it all circles back to how hematite forms.
Yeah.
Remember those banded iron formations we talked about? Ancient rocks with layers of hematite?
Right.
They formed billions of years ago when Earth's atmosphere had very little oxygen.
Right, those were like time capsules showing us what Earth was like way back when. But how does that tie into the search for alien life?
Well, those formations tell us that hematite played a crucial role in Earth's early history, particularly in the oxygenation of our atmosphere.
Mm-hmm.
And where there's oxygen, there's a good chance of finding life, at least the kind of life we know.
Okay, that makes sense. So if we find hematite on other planets or moons, it could mean those places might have had the right conditions for life at some point.
Exactly. Now, it's not a guaranteed sign of life, but it's a huge clue. It's like finding a fossil of an ancient campfire.
Okay.
It does mean someone's still roasting marshmallows, but it tells us the potential was there.
So instead of looking for little green men, scientists are on the hunt for rusty red rocks as a sign of alien life. That's way cooler.
It's all about finding those biosignatures, those traces of life that might be hiding in plain sight. And hematite, with its unique properties and history, is definitely on the short list of minerals that get astrobiologists excited.
I can see why. It's mind-blowing to think that something as seemingly ordinary as hematite might unlock the secrets of life beyond Earth. But before we get too caught up in interstellar adventures, we haven't even touched on hematite's modern uses. I mean, besides potentially pointing us to alien civilizations, what's this mineral up to these days?
Hematite is still a busy mineral, even here on Earth. Remember how we talked about its density?
Yeah.
That makes it incredibly valuable. For instance, did you know that hematite is used in radiation shielding?
Wait, seriously, so the same mineral that colors ancient cave paintings is protecting us from radiation?
You got it. Its density makes it incredibly effective at blocking radiation, so it's used in medical equipment and other areas where radiation protection is critical.
Wow, talk about a career change. From cave paintings to high-tech medical equipment, this mineral really gets around.
And it doesn't stop there. Hematite is also used as ballast in ships.
Ballast. You mean like those heavy things they put in boats to keep them from tipping over?
Exactly. Hematite's density makes it perfect for that. Plus, it's relatively inexpensive and readily available. And if that weren't enough, it's even used in separating coal from impurities.
Hold on. From ancient pigments to space exploration to keeping our ships afloat and our energy sources clean, is there anything this mineral can't do? I'm starting to think we've underestimated hematite all along.
It's a testament to how versatile and valuable this mineral truly is. But, there's one more surprise up hematite's sleeve that we haven't even touched on yet.
Oh, come on, another one. Don't leave me hanging again. What else is there to discover about this seemingly simple mineral? Okay, you've convinced me. Hematite is way more interesting than I ever imagined. But don't leave me in suspense. What's this final surprise you mentioned?
Well, we've talked about hematite's ancient uses, its modern applications, even its potential role in the search for extraterrestrial life. But what if I told you this seemingly humble mineral also has a surprising connection to some of the most cutting-edge technology being developed today?
Okay, now I'm really intrigued. We've gone from cave paintings to spaceships to what? Nanobots? Artificial intelligence?
Not quite, but you're on the right track. Hematite is being explored for its potential in fields like renewable energy and data storage.
Wait, hold up. Renewable energy? Are you saying my solar panels might be powered by rust someday?
Well, not exactly rust, but the same properties that make hematite so useful in other applications. Its conductivity, its ability to absorb light, also make it a promising candidate for things like solar cells and photocatalysts.
So hematite could help us harness the power of the sun more efficiently. That's incredible. And what about data storage? How does hematite fit into that world?
Think about the ever-increasing demand for data storage. We're generating more data than ever before, and we need new ways to store it all.
Right, and I'm guessing those tiny flash drives aren't going to cut it for much longer.
Exactly. That's where hematite comes in. Researchers are exploring its potential in developing new types of memory devices that could revolutionize data storage.
Wow, this is blowing my mind. From ancient pigments to the future of technology, hematite has truly stood the test of time.
It's a true testament to the power of scientific inquiry and the importance of looking beyond the surface to discover the hidden potential of the world around us.
Couldn't have said it better myself. So the next time you spot something rusty, don't just dismiss it as mundane. Take a closer look, think about the intricate processes that created that rust, and consider its vast and surprising connections from the art of our ancestors to the technology of the future. You never know what hidden depths you might uncover.